Hello everyone, today we'll be discussing another LeetCode question. This question is the part of the daily question and this requires one algorithm, uh, which is basically used to calculate the prime numbers between ranges. So we'll first quickly discuss what the question is. The question is simple. The question here is we are given two numbers 10 to 19, and between all the numbers that are prime between them, like let's say between 10 and 19, we have 11, 13 and 17 and 19 prime numbers. So we have to find the pair which has the shortest distance, like which has the minimum difference basically. So they both are having the same difference, so we have to find that pair which has the minimum value of left. This is left, so minimum value of left, that's why we'll take 11, 13. So that is the answer in the given question as well. So next up we have 4 and 6. Between 4 and 6, and remember both of them are included, like 4 and 6 will be included, but both of them are not prime. Okay, just 5 is prime, so there is no pair that exists, so we have to return -1 comma -1. So it looks simple till now, but here we have to utilize a um, algorithm for this, basically to calculate the number of primes up till a given number, like um let's say how many primes are there till 17. So what we do is we start from 2, and we in the uh, in the non primes we'll add all the multiples of 2, like 2, 4, 6, 8, and 2, 4, 6, 8, 10, 12, so on and so forth. Then we will go to 3, and we'll add all the multiples of 3. So basically 6 is there, and we'll add 9, and we'll add 12 is already there. So we'll add 15, so on and so forth. Like you will, and as soon as it crosses 17, we'll have to stop. But here's the catch. We see that there are several numbers which are being repeated. Okay, so how to optimize this basically? And one more thing, we have the initial number that 2, 3 will go till this number's square is less than 70s, less than or equal to 17, whose square is less than or equal to 17. So it's 4, right? 4's square is less than or equal to 17, because 5's square is greater than 17, so we don't have to consider 5, we have to consider 4. So quickly coming back, so we'll basically add all the multiples of 2, we'll add all multiples of 3, we'll add all multiples of 4, and all these are the non-primes. Whatever we get in the result, these are the non-primes. Of course 2 is a prime, so we'll not consider that, and we'll initially append 1 because 1 is a non-prime, and these are the non-primes, and remaining elements are prime. All the elements remaining between 1 and 17 are considered prime, and the list which is formed by our algorithm are the non-primes. Now there is a catch. We don't have to start with the first multiple. Okay, so we don't have to start if it is 3, we don't have to start from 3 into 1 or 3 into 2. We have to start from the squared multiple. So basically, what is the square of 3? 3's square is 9. Okay, so when we are at 2, we'll start from 4, and we'll start adding from 4. After from 4, we'll add 2 to 4, 2 to 4, and we'll add it to the list. Then we'll add 2 to 6, then we'll add it to the list. Then we'll add 2 to 8, then we'll add it to the list. Similarly, for 3, we are not going to start from 3 into 2, 6, because it is already covered in the previous iteration of some number. Previous iteration of 2, it is covered. We have to start from the ninth. Okay, so we have to start from 9. So basically 3 into 3 is 9. Then next up we'll add 315. Next up we'll add 318, which is outside 17, which is greater than 17, so we'll not add it. So basically this is the algorithm which we have implemented over here. Here you can see we have started from I equals to 2, and uh, we have from the while loop we have seen if it is, we have to uh, we'll have to increment I till its square is less than right, and then fill after that if I not in non-prime, then what we are doing is we are just taking a multiple using j, the loop for j, and it is starting from I into I, and it goes up till I plus 1, and it is incremented by I. So yeah, this is the way we are continuing. And there is one more thing at the end, we have to add one because that is a non-prime. Then what we do is, yeah, there's one more thing. Once we get this list, we have to basically take the list that lies between left and right. Okay, because we don't have to consider the numbers that are not required. For example, in this first example, we have to take from 10 to 19. So we will just take 11, 13, 17, 19. We are not bothered about other prime numbers. And this is a list of prime. Okay, this is a list of non-prime. So one thing that we have to do is, while iterating over that list, if there is a I that is not present in that list, then we have to create a list of prime as well. Okay, because this, the list that is formed using the algorithms, are the list of non-primes, and we have to find the primes. So we will iterate over that list, and if we'll see, if we'll iterate between left and right, and we'll see if a number is not present in non-prime, then we'll append it to the list of prime. Okay, so this is there. And then what we'll do, let's say at the end we got this list, so we'll iterate from the left, and we'll see if the gap is maximum somewhere. We have to basically store 11 and 13 somewhere. Similar start, we'll start from 19, 17. We'll see that the gap is something 2. We come to 13 and 70, the gap becomes 4, so this is not the answer. We come to 13 and 11, uh, the gap is 2, which is equal to 17 and 19. But since we are iterating from left to right, the answer will be the leftmost. From right to left, the answer will be the leftmost, because if there is a tie between the gap, here is a tie, right, between 11 and 13 and 17 and 19. So we have to choose the minimum number, minimum where the value of the first number is minimum. We have to choose from that. So this is the way we have to solve this, and this is a medium level question. We have to remember the algorithm. That is the catch here. But yeah, it's understandable as well. So basically, while finding primes, we are calculating the gaps. If we are taking 2's multiple, the first multiple of any number who was not previously a multiple of something is 2 is the first multiple of itself, 2 into 1. 3 is the first multiple of itself, 3 into 1. 5 is the first multiple of itself. With first multiple, I mean that 5 is not caught by multiplying some previous number. Okay, 7 is same, 11 is same. So basically, that's what we have to do. And yeah, that is the answer. That is the way to solve it. This is a Python code. You can take a snapshot of this, but yeah, attempt it yourself first. That will be actually a learning experience. So thanks a lot for watching this. Please like and subscribe, and see you in the next video.